Everyone, welcome back to another video for ICM, the Python version. In this video, we are going to start talking about some of the basics of collision and also how we can abstract some concepts out to create functions that return values as opposed to just functions that are making things happen on the screen. So to get started, I have a blank project with just a rectangle, and you'll notice I've changed the fill color of the text in the corner to black just to make sure that we can all see it as we're working together. If you'd like to code along with me, please feel free to pause, open up a new Trinket project or a project in whatever IDE you're using, and just get this rectangle set up on your page. If you don't want to follow along, you're welcome to just listen, and remember you can pause, rewind, rewatch the video whenever you would like. So starting out, I see that I have this rectangle, it's pretty big. I see that the XY coordinate of this top left corner are at 150. And I see that it is 200 units in width and 150 in height. And by units, we do mean pixels. So what I would like to have happen in this program is I would like that when I move my mouse over this rectangle, I want something to happen, like perhaps the rectangle changes colors. So I'm actually going to go ahead and set up a variable for myself called rect color. And I'm going to give rect color a starting value of, I don't know, we'll do this. And I can go ahead and fill that in just so that I have it. And again, if you missed any of that, you're welcome to pause and go back. But now I have a yellow rectangle, and I'm still having this conundrum where I would like it to change color when I'm on top of the rectangle and only when I am on top of the rectangle. So to do that, you may be thinking we could make it conditional, and you're exactly right. I think that's probably where I want to start this. But I need to know, how can I tell the computer that it's on top of the rectangle? And the answer to that is I can look at where my mouse is and I can look at the coordinates. So I need to know what are the values of all the possible coordinates in my rectangle. Now, something I noticed is that when I'm on my rectangle, my numbers are never less than 100 and they are never more than 300. When they become more than 300, like it's 301 right now, my mouse is actually on the outside of that rectangle. And this makes a lot of sense from my code because I told the rectangle to start drawing at 100 on the x-axis, and I told it to be 200 pixels wide. When I do 100 plus 200, we wind up with the range between 100 and 300. Now, the same is true for the y position and the height. I told it to start drawing my rectangle at 50 on the y-axis. So the lowest value I can get to and still be considered in my rectangle is 50. And the highest I can get to is 200 because we are taking that 50 and that 150 and we're adding them together. So we can use all of this to create a conditional statement that will decide what's happening here. So I can say that if mouse x is greater than 100, because I know 100 is my lowest number, and mouse x is less than 300, and mouse y is bigger than 50, but also it's less than 200, which again, that 200 is coming from 50 plus 150, and that 300 is coming from 100 plus 200. So if all these things are true, if my mouse x is bigger than 100 but less than 300, and the mouse y is bigger than 50 and less than 300, then I know I'm on top of that rectangle. And so I can do a few things. The first thing I'm going to do is add in a console log because I think that's useful. I'm just going to say on rect. And the second thing is I'm going to change the color of the rectangle. So I'm going to say that rect color equals color. We're going to turn it magenta because as we know, that's always a go-to for me. And then I'm going to put a console log in that will also change it back to yellow. I'm just going to do that right away to make sure I have both. So I have an if, I have an else. Now I'm going to stop it. I'm going to play. And it looks like it's mad because I forgot to tell it that I'm using a global variable. So at the top, let it know in my draw function that I'm referencing global rect color. Perfect. My error is cleared up. I'm going to move my mouse across the screen. Nothing, 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 nothing. Oh, console.log. It's not console.log because I'm not in JavaScript. It's print. Confusing languages left and right. If we had been in JavaScript, well, it wouldn't have worked for other reasons, but that line would have been good. If I want something to show up in the console on Python, it is print. Sorry for the confusion. So now I'm going to run it. Let's see if there's any other errors for me to catch. Nothing, 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 nothing. It turns magenta, it tells me I'm on the rectangle, and when I move off, it turns pink. And I can test this from all sides. I can make sure that anywhere on the rectangle it stays pink, but this now works. This is cool, and we've become very powerful, but let's imagine a program with a lot of rectangles. If I had a lot of rectangles and I wanted them all to change based on if my mouse is on them or not, I'd have to repeat this long and somewhat unwieldy conditional every single time to make that happen. And this is where writing functions and thinking about abstraction can come in handy. Because I know that even though I filled in specific values for this rectangle, I can actually abstract out and generalize a rule to know if I'm on top of all rectangles. And that's what we're going to do together right now. So I'm going to go ahead and comment all of my conditional out. I want it to not be running anymore because I'm going to write and test a new function. And I'm going to head up to the top of my screen right underneath all those imports to start defining a function. So I'm going to just make a note that functions are here. I'm making that note so that I can find them if I ever need to go back and edit anything. And I'm going to call this function mouse on rect. So when I'm looking at this function mouse on rect, my dream is I want it to be a conditional kind of like this, but instead of just changing the color, I want to think bigger. I want a function that is just going to report back, am I on the rectangle or not, and let the computer use that because I might not always want to change the color of the rectangle. Maybe I'm coding a game and when I'm on the right space, something's going to unlock. It doesn't necessarily involve a color, but it does, the computer needs to know that I found like that secret rectangle, that I'm on the right space. So when I'm trying to decide if my mouse is on my rectangle or not, I think I'm going to need some information about the rectangle. I think I am always going to need the X, the Y, the width, and the height. Now, as I start coding this, I'm going to think about the general rule for what we said here. So mouse X is bigger than 100 is important, but not because it's the number 100, because that's the starting X position. So I know that mouse X always needs to be bigger than the X position of my rectangle. And I can even make a little note here that X, Y, width, height all relate to a rectangle. Now notice it says a rectangle because I'm going to be able to use this function on any rectangle. So if mouse X is bigger than the X position and mouse X is less than the X position plus the width, because that's where this was happening, then I'm definitely on it left to right. But now let's deal with the Y. So I know mouse Y also has to be bigger than the Y position, and mouse Y has to be less than the Y position plus the height. All of this together is the same thing we said here. It just took away the specific numbers so that it is a rule that could now be used in any situation. Now we said I don't want it to necessarily change a color, but what I do want it to do is return a value to the program. Now this is a little confusing, but we have seen things that return values before, like random is a fantastic example of that. When a function returns something, it's not making something flashy happen on the screen. It's just giving the computer back some information. So I'm going to say return true, and it's true with a capital T in Python. And if that is not happening, I want it to return false. Now here's the beauty of this that we're going to see happening right here. Before I use any type of conditional, I'm just going to print out the results of this function. So I'm going to say mouse on rect. I'm going to plug in my rectangle values. And I just want to run it and see what happens. So you see it's saying false all the time. When I move on top of my rectangle, it should, oops, I put 500 instead of 50. I'm making mistakes all over the place today. So it's saying false all the time. When I move on top of my rectangle, it's suddenly saying true. And when I move off, it's saying false. And I know you are probably wondering, why is that useful? Nothing has happened on the screen. But remember, true and false are a Boolean. And when I'm writing conditional statements, that whole thing after the if or after the elif, that's a Boolean. It's reporting back to the computer true or false. And that true or false is deciding if the conditional statement runs or not. So I'm going to rewrite a conditional that's going to be much shorter than I had before. I'm going to say if mouse on rect, and I'm going to plug in my information from before. That's all I have to say, if mouse on rect, because that is going to be saying true or false. If I feel more comfortable, I could put a double equals and I could put the sign true so that it reads more like a statement that we've read before. It is not necessary, but I could do this. It makes me feel more comfortable. I could have it print out on rect, and I could change the rect color to color magenta, just like we did before. And I can even have my else with my rect color changing back to yellow. Now, this whole conditional, the same stuff is happening inside of it, but this up top, so much shorter than what we wrote before. I no longer have to think through all that logic because I captured that rule. Now I'm just plugging things in to make it run. So if I hit stop and then run, you'll see that I get my pink and then I get my yellow, just as if I was using that longer conditional. And the added bonus now is if you imagine I had several other rectangles on the page, I could write a conditional like this for every single one that just utilizes this mouse on rect function instead of having to write all of this every single time, which is pretty cool and pretty powerful and a very strong argument for why we should always be using functions. Now, I know what some of you might be thinking. This is just for a rectangle. So glad you asked. There are ways that you could mathematically write this for all the other shapes in the world. However, that's going to take a lot of mathematical thinking, and it also means that you might potentially need to rewrite that for every program you ever want to look for collision in. And so to make your life easier, as a part of this curriculum, we've already looked at the fantastic mathematical thinking done by Jeffrey Thompson, and we have turned a bunch of these rules into functions already. This is our Collide library. You'll see it linked in the curriculum. And this is something that you are going to be able to put into any program you want and utilize to decide if collisions are happening. You'll notice that in the main.py, I'm already importing it up here. So I could have actually skipped all these steps and just used an imported function. That's not what this video is for. This video is for talking about returning values. We're going to have another video on returning values in a different context, and then we'll start talking about how you can use this Collide 2D library to make all of your collision dreams come true. Thank you so much. I'll see you in the next video.